Greetings and welcome, friends. We are taking a look at last night's quest, page 65 from the Big Ideas Algebra 1 textbook. We are solving inequalities. Sadly, we're not solving injustice in the world and inequality. We're just solving math inequalities, which are still helpful, I assure you, but no, Bruce Wayne will be disappointed with this video. We are not solving the world's inequality problems. We are not promoting vigilante justice here or anything like that. But here we go. If you wanted to solve inequalities, this is how you would do it. We would use inverse operations, and specifically in this video, we're talking about using addition and subtraction properties of inequality. The idea that I can add the same thing to both sides of an inequality and it will be consistent in its inequality direction here. So here we go. Let's just jump right in. Question 7. I've got x minus 4 is less than negative 5. And what I can do to get x, the variable by itself, which is what I mean by solve, get the variable isolated, I will do the inverse operation of subtracting 4, which is adding 4 to both sides. So plus 4, write them underneath their like terms. How wonderful is that? And I'm going to have x. The sign stays the same, just x is less than, and negative 5 plus 4. Oh boy. Here we go, guys. The signs are different. When the signs are different, I subtract the numbers. So 5 minus 4 is 1. And I'm going to take the sign of the more influential one, which is 5. So 5 was negative, so 1 will be negative. So x is less than negative 1 is the solution. Let's see, they want us to graph. Let's see, ooh, I've got my nice, this number line is going to be so amazing. Here we go. Check this out, and I'm going to preemptively draw a number line over here. Hopefully it'll be enough space. So when I graph this, right now we are dealing with one-dimensional graphs, number line graphs. And my graphs, I'm not looking for, graphs that are drawn by the artist Michelangelo or the Ninja Turtle for that matter. Just like, well, actually, maybe Ninja Turtle quality. They've only got 3 fingers. I wonder how well they can hold a pencil. They could do it. They're fine. So anyways, you just got to tell me where 0 is. And then the point of interest, which is negative 1 here. So that would be to the left of 0 because this is the negative axis. This is the positive. Right. And now I'm going to plot my solutions. So my solutions here are all values of x that are less than negative 1. Less than, not equal. If it had the equal to part, then I would put a solid dot there, but it's less than, it doesn't include it, so I'm going to put what we call an open circle here. All right. And less than would be everything to the left than it. That almost worked. Left than it. Yeah, there we go. So I'm shading it to the left. And remember, as long as you have your variable on the left-hand side of this inequality, the symbol itself will act like a little arrow telling you which way to shade. How great is that? Oh, it's adorable. It's a cute little arrow. Oh. So here we go. So my solutions are everything less than negative 1, not including negative 1. So like negative 2 works, negative 1.5 works, negative 1.1 works, negative 1.0000001 works, but negative 1, no go, no go. All right, here, question 19. I didn't end up assigning this last night, but I like this one because it kind of at least was a little bit more interesting. This one had some simplification taking place first. I've got 3 minus 2, and I should combine like terms first. They're on the same side of the equal sign, so I don't have to move one to the other. And when I combine like terms, I simply add or subtract their coefficients. The variable remains the same. So I'm going to have 10 is greater than or equal to 3p minus 2p is 1p, minus 7 still hanging out here. All right, so far we're good. So to get the variable by itself, we will add 7 to both sides. Both sides of the inequality or equal sign. In this case, we're dealing with inequalities. So I will have 17 is greater than or equal to p. And then let's flip this using a, nope. Man, I always want to call it reflexive. Symmetric property. We'll flip it. So I'll have p compared to 17. And when I flip it, the inequality flips as well, friends. So there is my solution set. There are infinitely many numbers that are less than or equal to 17. So there's a lot of them there. So I will, let's see, plot, let's put 0 here. Let's put 17 would have been to the right of it. The positive would be over there, the negative over there, but you don't have to label those. So less than or equal means it would include 17. So I'll put a solid dot. Oh, you gotta select the right color, hue, tone, saturation, something there. I don't know, I'm not an artist. I'm also not a Ninja Turtle, in case any of you guys were wondering. I figured it was obvious, but just in case it needed to be said. So solid is because of the equal part there, and less, so to the left. And shade it to the left. There we go. Look at that. Gorgeous. And if I wanted to test a solution, which this didn't ask us to do a check, but I could just pick any number in the shaded region. 0 is always my favorite, and try plugging 0 in for the variable in the original problem, and it should work out. So for instance, you don't have to write this down. You didn't even have to do it for the problem, but watch this. 10, is that greater than or equal to 3 times 0 minus 2 times 0 minus 7? Well, this is 0. This is 0. 0 minus 0 is 0. 10 is greater than or equal to negative 7. Is that true? Yeah. 10 is bigger than negative 7. I love it. I love it. Okay, let's take a look at another problem here. Okay, this says, write the sentence as an inequality and then solve the inequality. Man, these ones I always got to think about. All right, so the difference of a number and 9 is fewer than. So this is the relational language, right, where I'm comparing these two things, and I've got to figure out what that means. And guys, let's see if we can do that. We did have a chart the other day that would just like tell us it, but I want to like try to think this out. That was a closed circle because it had the equal part. Let's see, so it says the difference of a number and 9. Difference means subtraction. The number would just be some variable. So x minus 9 is fewer than 4. So is fewer than, so this is going to be smaller than 4, so that sounds like less than. Does it sound like it could include 4? Could it ever be equal to 4 based on that language? I don't think so. I think is fewer than is just going to be less than. So I feel comfortable with this arrangement. And now in order to solve this, to get the variable by itself, we will add 9 to both sides. There we go. So we will have x is less than 13 are the solutions to the inequality. They didn't ask us to graph in this case, so I'm not going to graph. But also, you could just think of what numbers are less than 13. Well, 0 is, and I could do a quick check that way. 0 minus 9 is the same as negative 9. Is negative 9 less than 4? Yeah, so it seems like that kind of makes sense. Seems like. Let's check out one more problem, last one. I think we're doing good for time. Yeah, we are. All right, question 25. You are riding on a train. Guys, I feel it, like I'm visualizing it. Like, just imagine, like me hanging out on a train. Maybe, no, it definitely is Thomas the Tank Engine. Yeah, me and Thomas were out on adventures on the island of Sodor, which I always think Sodor sounds like Mordor, and actually Thomas going to like Mordor to destroy a ring would have been a really cool movie. Maybe they'll do that someday, like a crossover, just him and Frodo, you know, taking a train to Mordor. Man, I love it. Man, I've got to edit this out of this video because my fan fiction right here is so great. Someone's going to make a movie out of it and steal my idea. Well, I've also got to register the website www.sodorismordor.com. So I'll have to do that before I post this video. It says, you are riding on a train. Man, guys, you are there now. You can visualize this, right? Your carry-on bag can weigh no more than 50 pounds. Man, Frodo, I understand that ring is a burden. It's so difficult to carry, right? Okay, your bag weighs 38 pounds. Write and solve an inequality that represents, and check out this question, how much weight you can add to your bag. They just told us, right, how much weight you can add to your bag. When they say something like that, that is going to be our variable, okay? that is going to be our variable. So let's define a variable here. So variable, I'm going to say, let's call it W1 because of Watty, and then 2 because of, like, I don't know, weighs. I guess I could have also had P for pounds, something like that. W will represent how much weight I can add to my bag. So I could literally just say how much weight I could add to my bag. I'll just write amount of weight I can add to bag. And remember, if you do, for some reason, add more weight than is allowed, Sam Wisegamgee is going to carry you up Mount Doom anyway, so you'll be fine. And that guy's a beast, even though he's just your gardener. So the amount of weight, what is this measured in? Is this measured in, like, gallons of water? No, that's not a weight. But if I had gallons of water at a certain elevation at a certain temperature, that would be. What's this measured in? What is the weight measured in? Ounces, grams, pounds, right? LBS. Okay, so it's a good idea to know that. Let's write our equation. In this case, it's an inequality. So your carry-on bag can weigh no more than 50 pounds. Your bag weighs 38. So I know that the amount of weight that I add plus the amount my bag currently weighs has to be no more than 50 pounds. So that sounds like it's got to be less than or equal. You think it sounds like equal? No more than, it can't be more, but it can be equal. Yeah. So no more than 50 pounds. So there's my inequality done. Let's see. And then it says solve it. Solve this inequality. So to solve this, I would subtract 38 from both sides, right? Inverse operation of addition. And notice the benefit of isolating my variable is it will then answer the question, right? How much weight I can add to my bag, which is what I want to know, right? So W is less than or equal to, oh dear, 50 minus 38. Let's see, 50 minus 30 would be 20. Minus another 8 is 12. Okay. So W is less than or equal to 12. All right. Now let me see what their next question is. I'll answer this actually first. I'll say man, that's the worst Y I've ever seen. You can add 12 more pounds. Right? And when you write the answer to a word problem, all you're doing is combining the variable and the solution. Right? So literally I'm like, okay, the amount of weight I can add to my bag is 12 measured in pounds, right? I mean, like I could practically program a robot to write this as long as the variable and solution are done. And those pieces can be hard. That would be much harder to program a robot to be able to read a word problem and then write an equation related to it. That would be tough. But let's see, there's a part B here, I thought. No. Huh. Let me see if I can find part B real quick while the internet waits. Part B. Here we go. All right, I found it. I must have undoed it before I started writing stuff. That's okay. Part B, done. It says you can add both a 9-pound laptop and a 5-pound pair of boots to your bag with. Oh, can you? Sorry, I was like, I don't think I can. Can you add both a 9-pound laptop and a 5-pound pair of boots to your bag without going over the weight limit? Explain. What are your guys' thoughts? I think no is the answer, right? Because 9 plus 5 is greater than 12. Would be my reason. What's 9 plus 5? 14. Is 14 less than or equal to 12? No. Or I could have said 9 plus 5 is not less than or equal to 12. Someone's whistling here. And it ain't Thomas the Tank Engine. I don't know. Our school makes all sorts of weird noises. But anyways, so yeah, you're going to have to leave one of those things behind. You could pack either of them, though. Yeah, so yeah, there you go. Well, thank you for watching, Internet friends. Hopefully you have a great day. And remember, www.sodorismordor.com. Bye-bye.